That works. I mean, I can also, if I'm running out of time, wave me down and I'll adjust on the fly. But yeah, hook me on.
You're fine.
Think we have an hour?
Yeah.
Okay, so it's.
Yeah, we have it tomorrow.
Oh, it should be. Sure to leave.
Hello, everyone. May I have your attention, please? Yeah. Thank you so much, everyone, for joining today's presentation. I really appreciate. Today we have Carly Ziter. I was our presenter and guest. So then she will talk about urban ecology and sustainability. Personally, I teach ecology in milk production. And through this course, myself, I learned that how different ecosystem and ecology concept aspects affects our daily life and their environment. So then it's brings to our environment and our ecosystem. So Carly Ziter is assistant professor in biology department of Concordia University, Montreal, where she holds a university research chair in urban ecology and sustainability. She completed master in biology and natural resources science at McGill and PhD in landscape ecology at the University of Urban ecologist. Her research asks how landscape structure, land use history, biodiversity impact multiple ecosystem service, which we are more interested to know about this, and the benefits we receive from nature and their relationship in urban areas. Ziter and her student combined field-based studies, sensors, satellite data, community science, and synthesis approach to ask ecology questions related to urban sustainability policy and practice. Ziter often collaborates with non-academic partners from grassroots community groups to federal government scientists and is committed to integrate public engagement and science communication into her science work. So we do have 1 hour time. So then the presentation should be about 45 minutes, and we will have time for question at the end. So then if you have any question, I would assume that you prefer to write down the question and we have a discussion at the end. Okay.
Sure.
Yeah.
Yep, we can do that. And I can also stick around a little bit after, if you're shy and you want to come and ask me a question, not in front of everyone,
Okay.
you can do that as well.
Here you are. Yeah. Thank you so
Okay,
much.
well, thank you very much for such a kind introduction and for inviting me.
I'm just gonna stop 1 second.
Yes.
I don't think the people online can see.
Oh, okay.
So
Are we not
I
share?
don't think we're sharing that through the system.
Oh, share.
Yeah.
Classroom, so that the screens around.
Yes, is probably worse.
There it is.
Okay.
It's gone and also. You can see it, yeah.
Okay.
Good. It was on.
Okay, are you
Yeah, it's moving.
beautiful? Okay, well, thank you very much for that very kind introduction. And I've had a really nice visit and meeting with people yesterday. And so today from Concord, Joke, which is on the territory. Work. Ecosystem services across the land, which is a very broad and lofty goal that I'm sure I will still be working on, 30 years from now. And I'm going to start by acknowledging a lot of people. So I don't do my work alone. By far, my favorite part of being a professor is all of the incredible people I get to work with. So this is my research lab up there, a really excellent group of undergraduate through postdoctoral researchers. And we also have a lot of collaborators, not all of whom will show up in today's talk, but who all inform the kind of science I do. And these range from ornithologists, foresters, ecologists, engineers, political scientists, urbanists, across a diversity of disciplines to help us do the kind of work we do. And we have support from many, many local organizations and local people who inform our science. So I got my start in research and really developed my love for ecology as a field ecologist, going out, catching fish, collecting seeds, measuring trees out in these kind of wild and working landscapes that I think many ecologists are attracted to early in their careers. And throughout my PhD and into my current position, I, and really now my students down there, transitioned to working in sites that look a little more like this. We traded those wilder landscapes for these living landscapes that make up our cities and towns. So you'll often find us, digging up people's backyards or in our local community gardens. And part of the reason that this ecology, this urban ecology, is so important to me is that we live in an increasingly urban world. Urban land use is among the fastest growing land use classes worldwide. For the first time in history, more than half of people in the planet live in a city. 4 out of every 5 Canadians live in an urban center. And many scientists, including myself, have really been grappling with, what does this mean? How do we conserve nature for biodiversity, for human well-being in this increasingly urban world? And on a global scale, we know that urbanization presents some serious challenges. We're building the equivalent of a city with the population of London, England every few months on the planet. These cities often sprawl into natural habitat, they can release carbon, they can damage vulnerable coastal regions if they're unplanned. And I think this is a story we hear a lot about, these big challenges of urbanization. But this isn't just about global numbers. Challenges of urbanization exist across a really big range of scales, right? You have biodiversity change from, local extinctions or introductions in a neighborhood all the way through to the spread of invasive species through global shipping or trade. We have changes in ecosystem services that range from local factors like the increase in urban heat as we build more buildings in our neighborhood through to changes to the global carbon cycle. These challenges get a lot of attention, rightfully so, but I am personally more interested in thinking about the opportunities. So thinking about where there might be opportunities to improve biodiversity and ecosystem services in this urban world. So can we focus on the positive impacts of small-scale habitats or more participation in biodiversity planning, or how we improve livability through the planting and management of our urban green spaces? And these opportunities are really echoed by kind of recent political targets. If you think about COP15 for biodiversity that just happened in Montreal, where I'm coming from, we heard a lot about this need to mainstream biodiversity into planning to ensure people have access to urban green and blue spaces where they live. And a lot of these opportunities tend to skew local. We see them over on this city and neighborhood side of our diagram. I think if we want to work towards a more sustainable urban world, we need to better understand the ecology of our cities and neighborhoods. And in our lab, we think a lot about this ecological fabric of our cities. Thinking about all of these diverse green spaces, from parks to yards to vacant lots to built green infrastructure like green alleys and facades and roofs. And we think about how can we better understand these spaces, both to support other species, to conserve biodiversity in our cities, and also to influence the health and well-being of our communities. So this idea of providing ecosystem services. And I'm going to back up and do a few definitions because I never quite know who's in the room when I'm giving a talk. And so when I talk about ecosystem services, a lot of you have probably come across this concept in your class or taught this concept to your classes. But really, I'm using that term to draw attention to the ways people depend on the environment. You might hear a lot of terminology. You will hear people talk about nature's benefits, nature's contributions to people, nature's gifts, natural capital. All of these terms, at the heart of it, are really a way for us to explain that we depend on nature to live kind of safer, healthier, richer lives. And an important part of this concept is that people, communities, are really instrumental in kind of mediating these benefits. Benefits aren't just like magically flowing from nature to us when we need them. We intervene, we manage these systems. And maybe silly for this audience, but when we talk about biodiversity, we're really talking about variety, right? Often this includes things like how many species are there, thinking about species richness, but we also think a lot about the specific characteristic or traits that these species have. And so now that we've gotten some terms out of the way, a way that I'd like to try and explain our really broad research program in the lab is that we think about the ways that cities, or more accurately us, the people who live in cities, need nature. Questions around, how do we assess the benefits of urban trees and soils? How does this intersection, these hybrid systems of kind of built and nature affect the benefits that are provided and how we can access them? But we also think about how nature needs cities, or how nature needs us to manage cities better for other species. And so thinking about, best practices in green space management to maintain plant or insect or bird diversity, how we implement these solutions. And we're trying to think of these together, right? Do these go hand in hand, where if we improve our cities for nature, does that also improve our cities for us? Or do we have to make some hard choices? We study many aspects of the urban environment in the lab, from trees to plants to soils to birds, but I'll admit that trees are my favorite. That's where my ecological background is more in trees and forestry. And luckily for me, trees play, or I'll make the argument that trees play a really kind of outsized role in shaping the ecological fabric of our cities. And so I'll start my talk focusing on trees, and we'll move on to other organisms later. Many of you have probably seen diagrams like this or used diagrams like this in your teaching or outreach, where we talk about all the benefits we get from trees. But where do these numbers come from, right? When we talk about trees cool city streets by some certain amount, how do we know what that amount is? And that's the kind of science that ecosystem service scientists tend to do, is trying to put numbers to a lot of these benefits. And so at the core of this work on urban heat that I'm going to start with is the urban heat island effect, where our downtowns, our cities are much hotter than surrounding areas. This time of year, it always feels a little silly to talk about this because it's like, oh, I'd take an extra couple of degrees out there. But this has serious health and safety implications for people who live in cities, particularly in the summer, particularly in places that may not have the infrastructure to deal with this kind of heat. And so as an example, in Montreal, when I was growing up, we would get about 8 degrees of the year. I didn't grow up in Montreal, but when I was growing up, the people in Montreal got about 8 days of the year over 30 degrees Celsius. By the time I retire from my new job, that number will go up to 50 days of the year over 30 degrees Celsius. That's pretty hot, especially if you don't have air conditioning, which many people in our communities don't. Even in kind of breezy oceanside Halifax, you'll go from only a single day over 30 degrees to more like 8 every summer. Decision makers want to cool cities down, but the best ways to do this aren't always clear, partly because a lot of our research has focused on what we might call these like park cool islands, these specific islands of green in the city that can be cool spaces. So we think about how the size and shape and distribution of parks affects our air temperature or our surface temperature. And those cool islands are really important. But we also know that our cities are really heterogeneous. They're really patchy. Most of us don't live in a park or even right next to one. And so if we want to improve climate adaptation strategies more broadly, we need a better understanding of how temperature varies at the kinds of scales that we live and work and play. And this brings me back to my favorite urban trees, because urban canopy might be a lever we can pull to mitigate city heat at really local scales that we can intervene through practice, through policy. And that's because we make a lot of decisions about the urban forest. Which trees do we treat or remove when we have disturbances or insect outbreaks? What kinds of trees do we plant and where? And that really shapes this kind of heat riskscape of the future. So a few years ago, we started to think, this is at the end of my PhD in Madison, about how air temperatures varied across these really heterogeneous urban landscapes. And what we really wanted to do, our key question, was just filling in this gap of, we know the areas with really high canopy are the cool spots and, our parking lots are the hot spots. But what is happening in this kind of messy middle where we have a really mix of surfaces? And this kind of nuance seems like something we should already know, but it is hard to tease out with things like categorical sampling if you're going out and putting out sensors or choosing sites to study. And we didn't want to miss some of that kind of middle ground of the city. And so how do you measure urban temperature at a really fine scale, while capturing this spatial change in lots of different explanatory variables on a grad student timeline and budget? And so in my case, I got really creative with my trusty commuter bicycle, and we built a weather station, which is pictured right here, that I could strap on the back of my bike. This is really beautiful art by Cornelia Lee. And then we could take that through the city and get a measurement about every 5 meters spatially. So we got this incredible spatial data set with this really unconventional method. I also got a lot of exercise. And so what we did is we chose 10 transects throughout the city that would pass through different amounts of canopy cover, different amounts of impervious cover. We rode them during the hottest part of the day, and some of them at night over the course of the entire summer. And I'm going to just zoom in on one example here to show you this data because I find it so cool. And so what you can see here is a path that would maybe take 10 or 15 minutes to bike. And we go from, densely canopied parks through to kind of neighborhoods that still have quite a lot of trees, into slightly more, suburban residential areas, out to, the shopping mall parking lot. And I'm going to color this white line based on the air temperature on a summer day in Madison. It's going to start over there. So as we're biking, we're seeing the air temperature change. And so this is ranging from about 27 to 31 degrees, which is a pretty substantial difference. That's what you would see, from the city to the countryside. And this is over the course of just a few kilometers. And so we saw these really fine scale changes in temperature, resulting in these huge fluctuations in air temperature. And this is about one transect of 85. And unfortunately, they don't let you submit this to a journal and say, look, I found something. You've got to do some quantifying of your data, right? And so how do we measure these patterns across 150,000 of these measurements? I'm going to go through this pretty quickly, but what we did, we had some stationary sensors in the center of the city that were our reference. So we could always say, no matter where we were, what day, what time, we always knew relative to that spot, how much hotter or cooler is it? And then we looked at what surrounded each of our measurement points. So we looked at how much canopy, how much impervious, how far we were from water or a lake that we know cools things down. And we did this at different scales. So 10 meters, that's about, a single downtown property, just, your backyard, to 30 meters, to 60, to 90, where we're getting into more of like a street or neighborhood sort of scale. We did a lot of statistics here. I won't get into it now, but you can ask me questions later to quantify this data. Think about the spatial and temporal autocorrelation that came with it. So we used generalized additive models, which are a type of model that lets you look at wiggly data or nonlinear relationships. And what this gave us was this really nice understanding, and I'll put the actual data on here in a minute, but as we increase our impervious cover, or as we increase our canopy cover, what happens to that relative air temperature? Relative to the hot downtown, how does it change? And we look at it across all of these different scales. And we see usually what we use in urban heat island modeling is impervious cover. As you pave, it gets hotter. This is expected. As you get to broader and broader scales, you get a steeper slope. So as you pave more and more and more of your city, you get a bigger increase in temperature. So far, so good. Now, what happens when you add canopy into the mix? We get a decrease in temperature, what we'd expect. Trees cool things down. But two things that I want to point out here are, one, the magnitude of this difference. So if you could get enough trees in, you can fully offset that warming effect. That temperature drop was as big or bigger than the temperature increase we got from pavement. But we also got this non-linearity. So you really need to push into pretty high levels of canopy, that 30 to 40% cover, before we saw that big drop in temperature at these broader scales. And so if we put these together, what I want you to look at here, we've got a shift in color and we've got all these little black points. So all those little black dots are where we had measurements from our bicycle. So you can see we covered that space really well, from areas that had no canopy, no impervious, all the way up to areas with, total canopy, total impervious. The reason you can have both of those is the scale is small, right? You can be standing on a paved road and overhead have full canopy. And you see there's maybe about a degree of variation in temperature at this tiny scale of a single yard. As we increase in scale, we see this broader range of temperature. So as we're getting towards a neighborhood scale, we're getting, 2.5, 3 degrees of difference on an average summer day, just from shifting these two variables of canopy and impervious. But we're also seeing all these black points shift out of that top corner, because at a neighborhood, you can't pave your whole neighborhood and also have complete canopy cover at a neighborhood, right? That's a problem in physics. So having done this, what everybody wants to know is, well, where do we plant the trees? And so this work tells us that urban forest management is a really powerful tool to mitigate that daytime heat. And just looking at the data, kind of pushing neighborhoods over that threshold will give you the kind of greatest temperature decline given a certain number of trees. That doesn't mean that kind of targeted local planting isn't effective. It just has less of an effect if you don't have canopy in the surrounding area. So if you're only going to plant a few trees, really plant them where they count, like right next to the bus stop, right next to the walking path where people are going to feel that small effect. And probably the most important point here is that we don't want to use this kind of data to forget low canopy areas. We don't want to take this like rich get richer approach where we say, okay, just push neighborhoods over that threshold and forget about the rest of them. Because we know there are really strong environmental injustice issues embedded in who has access to trees and green space already. So I see this as more of a goal of, how many neighborhoods can we get up to this level rather than do we leave some neighborhoods behind? And this is a really important paper by my colleague Chris Schell that talks about those kind of systemic biases that perpetuate through our cities, where we know the areas that have more trees, that have more green space, tend to be the wealthier, whiter areas of our cities. And this work really reinforces a proposed rule that I appreciate from my colleague Cecile Kemendijk. That is the 330-300. So everyone should see 3 trees from their window, 30% canopy cover in their neighborhood, and live 300 meters from a park. What I like about this rule is that we're not thinking about this at a full city scale, but at a local neighborhood scale. We don't just want a certain canopy cover across the whole city, because that gives you a lot of room for inequities. Some people have all the trees and some have none. Rather, we're saying, can we get this done on a neighborhood basis? We're still asking lots and lots of questions about trees and green spaces and temperature. We're working with community groups. We are looking at the distribution and structure of trees. We're building new bike sensors. Lots of students out there collecting data. I'm not going to talk more about this today because I want to give you kind of a broader range of what we're doing in the lab, but happy to talk and answer questions. What I do want to talk about is how this sort of finished research, this project I did as a PhD student trying to get a good measurement of one ecosystem service, really got me thinking in very different directions. And 2 questions that just kept coming up for me were, who's responsible for all these trees? Like if I'm coming out here as a scientist and saying, you got to plant 30 or 40% tree cover, who is doing that work? Who is retaining those trees? And then also, does this mean that urban climate adaptation is kind of incompatible with densification? If we have to get these high levels of canopy, can we do this in a dense or a compact city? And so first, let's start with the who. Who's responsible for planting and maintaining trees in our cities? Let's go back to an example of a nice residential area in Madison, pretty low density. We have really high tree cover. I'm just highlighting it here. And this is governed by multiple people because our cities are cut up into lots of different parcels and pieces. So what would this neighborhood look like if we got rid of all the private landowner contributions? Suddenly we've got a lot less canopy, right? So if I'm here as a scientist saying you need 40% canopy, that's just really not possible without a kind of all hands on deck approach to urban forestry. And this is not just true of Madison or Montreal, or this is a slide from Toronto with 60% of its trees on private property. This is true across many of our cities. And this is a really common challenge. So we know the trees in your backyard are important. How much do we know about these trees? So this is a snapshot of Montreal's public tree inventory for the neighborhood where our campus is. And it looks pretty good. There's a lot of dots there. We know about a lot of trees. Until you zoom in and you see how many trees are actually missing between those dots, all the backyards, all the schools, all the churches. And so Kaylee Taylor, who was a master's student, was really interested in this question. I'm going to try and play a video, and I don't know if the sound is going to work for you or the people online. And if it doesn't, we'll just skip it. If you can't hear online, I'm sorry.
My name is Kaylee Taylor, and I'm a master's student here at Concordia, doing my master's in biology. We have a really great public inventory of all the trees on public land in our parks and along streets here in Montreal, but we know very little about trees on private land. We wanted to launch a pilot project that asked citizens to go out in their backyards and kind of explore their own urban nature by identifying their trees so that we can get a better idea of what the urban forest actually looks like. The urban forest is really important for a multitude of reasons, apart from the benefits they provide our communities by giving places to recreate, providing aesthetic value in our backyards. They play a big role in controlling urban air temperature. They reduce the effects of urban heat islands. They improve our urban air quality, and they also sequester a ton of carbon. What brought me to Concordia was the value that they placed in the.
You're going to get a little ad for Concordia there at the end. So it's very nice in Montreal. Come join us. So Kaylee, as you heard from Kaylee, we have half a data set. Half a data set seems pretty good to most scientists, right? We know about half the trees. That's a lot of trees. What we don't necessarily know is how representative that data is. And Kaylee was really interested in this question of if we were to go out and look at trees, in institutions, in private yards, would this be reflective of what we see in our municipal data set? So she used a mixed method strategy. She had very good intentions and a wonderfully planned field season to go, door to door and look at neighbors and go into their backyards and measure trees. And this was the summer of 2020. And so very quickly, we decided that Kaylee could not be the typhoid Mary of COVID and could not go knocking door to door and go into people's yards. And so she did a really quick pivot, worked with our communications department and the university to launch a community science project where people could go out, measure their own trees, take their kids out while they're homeschooling them, take a circumference measurement of the trunk and 3 photos for identification that we would have our team identifying on the back end. Gradually, as restrictions lifted, we were also Kaylee was able to go out and sample. She did in a plot around Concordia's campus, all the street rights of way, all the parks to update our public tree inventory and all of the churches and schools in that area. You see that her residential submissions come from kind of a broader neighborhood because we wanted to just make sure we got enough of those. And so in the end, we had, thousands of trees really spanning these different governance types. And what she found was that private yards show higher overall species richness than other green space types. So this is just accounting for the sample coverage, our kind of effort going out and sampling. What did that species richness look like? And you can see this blue private residential line is really up higher than everything else. And 30% of the tree species we found were only found in people's backyards. We didn't see them anywhere else in the inventory. Those of you who work with urban forests are probably like, yes, this makes a lot of sense. We did find that in this neighborhood, which is a relatively old neighborhood, the largest trees, I think I have some arrows here. There we go. The largest trees, if we're looking at the DBH, that's just the diameter at breast height, or if you're small like me, the diameter at neck height. We see that the largest trees were really in the public right of way, these big old street trees, and some of them in parks, where in private yards, we tend to see much smaller trees. We thought maybe this was just newer trees, and so we looked at their maximum size expectation as well, and they're just smaller statured trees. A lot of people have small yards, small spaces. They want fruiting and flowering trees. She also saw some important differences in the species composition. And so looking at the 5 most common trees, first of all, we see a problem here where just a few trees are making up the vast majority of our inventory, even though there are many, many, many species. This is a common challenge in urban forestry. But we see some differences. Notably, we have here our eastern white cedar, a coniferous tree that is very common on private land, almost entirely absent in public. And so we're seeing not just different species, but different kind of functional groups, different types of trees which we think is really important for the overall kind of resilience of the urban forest. So by looking at this private land, we're getting a better understanding of our urban forest as a whole. Next, she wanted to look at these, what we call preference or service-based traits. So these are traits that are specifically chosen to match kind of benefits that people might want. So rather than, in forestry, where you might look at functional traits that are more related to the success and growth of these trees, we're looking at things like flowering or fall color or bark texture that are related to these ecosystem services. So we're not measuring services directly, but we're kind of getting a little bit of insight. And this is just a sample of the traits that she looked at. And what she found, to show a slightly complicated ordination here, we're looking across this whole kind of trait space. And when we look in purple at our street trees, we see that they're kind of tightly clustered. And so street to street to street, even though there was actually a lot of diversity and a lot of different species in these streets, they're all kind of characteristically similar. They tend to be kind of fast growing, nice fall color, tall trees. They're playing a particular role in the urban landscape. And those are the trees that we know the most about, that we're making kind of decisions and assumptions about our urban forestry based on, because we have them in our public inventories. When we look at yards here in blue, we see this really broad range of traits where people are probably choosing, very different things based on their own kind of personal preferences and choices. So we might see a little bit more multifunctionality in our landscape when we're considering these different pieces. And we're doing some work now where we're actually running surveys and asking people directly about, their preferences and their values related to urban trees, which will help us interpret. Including private trees in inventories leads to a better understanding of urban forest composition and structure, and things like community science and working with landowners can help us to gather that data. Public streets were species rich, densely planted. I didn't show all of this data and had large trees, but they were characteristically really similar. So a diversity of green space types, a diversity of people managing this system seems to improve multifunctionality. And we may be missing things. We may be biasing our understanding if we're only looking at the street trees to understand our. This is a single neighborhood perspective, right? So what comes next? We are expanding this project. We're working with Alain Paquette, a colleague of mine in Montreal. We've been starting to do a few more inventories in Montreal, but we're hoping to expand much more broadly and across other cities as well to replicate this type of work and better understand this system. So the next question was about kind of densification. So if we know, we need a lot of trees, there's a lot of people involved in managing them, but can we actually get them into our cities if our cities are very dense? So remember, we don't see a lot of, once we're at this 50, 70, 80% impervious, we don't see a lot of high canopy cover anymore because we can't get to it. And this relationship with temperatures is reinforced by other work that we've done. And so Emily, who I've covered her poor face with my text up there, did a study for her master's where she looked at the building cover of different parcels throughout Montreal and related that to temperature, where predictably, as you get more and more buildings, you get much higher temperatures. This is moderated by tree cover. Neighborhoods that fit in a lot of trees are still cooler. But eventually, when you're getting to these high amounts of building cover, this high density, you start reducing the opportunity to have this cool air. And so in addition to thinking about trees and how to map and measure them, we're really starting to think now about how do we explore some other ways that we can design our dense neighborhoods to provide people with ecosystem services and access to nature. For example, through integrating more greenery in kind of non-treed ways. And this path has launched a number of really collaborative projects with people outside of ecology in terms of how do we kind of green our great infrastructure? How do we expand that ecological fabric of our cities and have buildings? And then also, how do we get like the most bang for our buck out of the green spaces that we already have? And these kinds of projects mean ecologists need to be kind of at the table with architects, planners, engineers, landscape architects, And these areas of research about, how do we design green spaces for nature and people are much newer for me. So I'm going to give you a little like rapid fire snapshot of a few projects we're starting, and then you can invite me back in 5 years so I can tell you how they actually turn out. But we're thinking about green roofs. So Niraj Dayanandan is working on a meta-analysis of the effect of green roofs in cooling areas. How does that change with different types of green roofs in different parts of the world? We have Fatime, who was a practicing architect before coming back for her PhD, who's really thinking about how do we integrate greening and thermal comfort into walkability and things like, walk score indices. What is it that people are looking for, and how do we measure that? What kinds of measurements do we need to assess this? Is it satellite data? Is it street level vegetation? Is it surveys? We're working with Hien Pham and urbanism to think about the social and ecological benefits of green alleys throughout Montreal and Trois-Rivières, this kind of grassroots greening efforts, and a number more that I won't get into here. And so far, I've really prioritized what nature can kind of do for us, and a little bit about how biodiversity is important in sustaining those benefits. But the way that we manage our many other species, it's not just about us and our needs. And so for the remainder of the talk, the next, I don't know, 10, 15 minutes that I have left, I'm going to talk a little bit more about some work on this end of the spectrum on how we can come up with or think about, best practices for biodiversity. And this is where I really reach like beyond my own taxonomic depth and rely on collaborations with great colleagues to answer these questions, who are the true experts in, the birds and the bees and the other species that we'll see down here. And we're going to start with urban bees. We're going to start and finish with urban bees. I promise I won't throw too many more studies at you. So we're not the only one doing this kind of research. Urban pollinators have had, a bit of a moment in recent years. There's a lot of really excellent work on pollinator-friendly cities. And this is because cities have, numerous small green spaces that can support animals with smaller habitat requirements, like insects. Cities often have a high number of floral resources. People like to plant flowers. And cities can provide a refuge from agricultural chemicals or some of the other stressors that these might encounter. And so a lot of cities are actively trying to do better to mitigate these kind of harmful aspects of urban life for pollinators and create more of a safe haven for biodiversity. Montreal, for example, has recently released its first pollinator protection plan. Many other cities are interested in this as well. I know that's all true. Cities can be good places for bees, but the real reason I got into urban pollinator work is through my excellent colleagues who I wanted to collaborate with. And so we have down here, JP Lessard and our master student, Serena Sino, and up here, Dr. Gail McInnes, whose work I'm really going to focus on today, who's a pollination ecologist. And they were all very gracious in letting me kind of masquerade as an entomologist for a few years. And this is Gail, hard at work measuring, I believe, nectar concentrations of a flower. And she is kind of broadly interested in and concerned about these declines we're seeing in bee species richness. She has a decade of pollination ecology training. And shortly after I started my job, Gail showed up at my office and said, I hear you know something about cities. I've got a great idea for a project about our urban bees. Can we try this out? And that work that Gail proposed was really inspired by the work of our collaborator, Etienne Normandin, who's a taxonomic expert, who did a really thorough survey of wild bees through Montreal and Quebec City about 10 years ago. Since that survey, we have seen an explosion in urban beekeeping. And that's part of the reason that Gail was so interested in this data set, because we have had this surge in urban beekeeping. These red points are Etienne's original study sites where he sampled bees. And these brown points are just a portion of the honeybee hives that have been introduced to the city since then. It's actually very hard to find that data since the city doesn't keep a registry of hive locations and companies are pretty reticent to share it. We snagged this map before they took it away from the public. And so overall, by talking to our colleagues in the provincial government, there's been about 3,000 hives introduced to the city of Montreal over this period. I'm going to note up front, I have no vendetta against honeybees. My in-laws are beekeepers. I come from a beekeeping family. But is the city necessarily the right place for, tens of millions of honeybees, particularly given that many people think that they're doing something beneficial for conservation? When you talk to people, the reason they're introducing these hives is not as livestock or for the product of honey, but because they want to save the bees, they want to contribute to biodiversity. And so there's maybe a misconception here. Not maybe, there is a misconception. So can we find some evidence to better guide policies for how we might share our cities between biodiversity, our wild bees, and livestock that people want? And so Gail set out to ask whether urban beekeeping was impacting wild bee diversity in Montreal through competition for floral resources. Are there enough flowers, enough pollen and nectar to support this huge influx in pollinators? And so she hypothesized that regions of high honeybee abundance would have fewer wild bee species, as well as fewer floral resources like pollen. She went out, she resampled 15 of those sites from Etienne's original study that now sit along a gradient of honeybee hive density. Those included nature. Again, summer of 2020. So Gail put in an incredible effort managing this field season safely through the real early months of COVID and, getting out there and safely with all her permits doing this field work. We did unfortunately miss the May sampling due to those restrictions, but we were still able to get out for 5 sampling periods between June and September to do kind of active netting for bees as well as pan traps and looking at many of these attributes of the floral community. We looked at several covariates. So we looked at the amount of impervious surface surrounding these sites. Since that's uninhabitable, it's not good nest habitat for most species. We looked at the amount of herbaceous greenery, so a kind of general estimate of floral resource availability. But then to dig a little bit more into floral resources, Gail and our wonderful undergraduate Megan collected and counted pollen in a subset of white clover floret. So this is a common species across all of our sites that's kind of accessible and attractive to both honeybees and wild bees. So from this point on is where if you ask me questions, I'll start to reveal that I really study trees, but I'm going to do my best to do justice to Gail's incredible data set here. And so we sampled 120 species across 22 genera, many thousands of bees. Those were pretty dominated by honeybees. 40% of what we saw were honeybees, but we did get, a high diversity of other species, lots of Lesia blossom, Seratina, Hylaeus, so sweat bees, yellow-faced bees. And we did, in all the future analyses, take into account the kind of amount of sampling effort to make sure that we're kind of comparing apples to apples across all of our sites. And so to start, in our 2020 surveys, down here, we have our honeybee abundance. So this is the number of honeybee individuals that were counted during that 10-minute sampling period, and then our wild bee richness. And we do have a significant negative relationship. A few things that make this trend maybe more surprising. We know that the sites with the highest honeybee abundance over here are also our community gardens that are hotspots for wild bees, that we would actually expect the highest wild bees. Number of wild bees. We also know that many of these sites down here are cemeteries, which don't have the same amount of floral resources available, and we would expect to have lower bee diversity. Even with those things that we would expect to kind of balance out this line, we still see this negative relationship where as we get a higher abundance of honeybees, we get fewer wild bees. And we think that this is primarily driven by small bees. And so the small bee richness is where we see the strongest trend. This makes sense. Small bees have a much smaller foraging range. They can't just, go somewhere else to find floral resources if they're not in their immediate area. We also wanted to compare some of this to the past data. Now, of course, you can't just compare the total number of bees you found directly. There's so many other variables that will change between years. And so what we did, we looked at what was the increase in honeybees from what they found in 2013 to what we found in 2020. So sites where they didn't have a lot of honeybees then, they still don't have a lot of honeybees now. What did we find in 2013 in gray, what did we find in 2020 in black, through to sites where there used to be not very many honeybees, and now we've had a big increase. How much do we see that abundant or that diversity drop? And so you see, as we get to a larger and larger increase, this is just, oh, my diagram is missing up there. This is just all wild bees and small wild bees. So you'll see, you know, the same trend, but a little bit stronger for our small bees, where as we get to sites where we really saw a big influx of honeybees, we see more of a decline in wild bee richness relative to what we had then. So second line of evidence. We have a decrease in bee richness across a current gradient of honeybee density. We have a decrease compared to this baseline data. Let's add a third line of evidence. Gail is very thorough, and so she decided to also look at this pollen availability and what predicts this amount of pollen grains that were left per flower. And the strongest predictor of this was the abundance of honeybees. So areas where you had lots of honeybees, predictably, you had less pollen available, less left to support this broader bee community. And so that kind of lends some evidence to support that this is likely competition for resources. Now, on their own, there are limitations with, you know, any of these lines of evidence, right? We're looking at a snapshot in time. We know insect populations vary over space and time. We missed some important sampling periods, but again, we're still seeing, you know, over and over with each line of evidence that urban beekeeping is likely impacting wild bee diversity, especially of small bees. We didn't see an impact on wild bee abundance, so we still had lots of bees. We're just losing some species. So there are some winners and losers here. So 3 lines of evidence that we went through. And for me, this really highlights some of these misconceptions around urban biodiversity conservation and the need for evidence-based regulations. We're not saying, you know, we can't have honey in the city anymore, or we want to get rid of all hives. We're saying, let's think about why we're doing this. Is it for biodiversity? Is that actually helping biodiversity? And also, where can we put in place some regulations around how many urban hives we have and where we put them? And so a kind of low-hanging fruit sort of recommendation here is we should have a local hive registry that shows the location, so we can say, you know, okay, this neighborhood is already pretty saturated. Let's not add additional hives here. Can we share the city? This work came out last week, so if you want to read it, it's available. It's open access. It's in Peer J. This is a really excellent effort from Gail that we're very proud of. That was not super happy conservation news. So very, very briefly, to give a little bit more positive news, we're also thinking about what we can do to support a diversity of bees. And, you know, dense, diverse floral plantings do help, as we've seen in many other studies. And so Serena Sino's master's was looking at, you know, if we account for floral density, how many flowers are there? What else influences our wild bees? And she's finding that wild bee richness is positively related to variation in corolla length. So a diversity of flower sizes and shapes seem to support a diversity of bees. So this is helping get at maybe some of these ecological mechanisms for, you know, why do we want to plant a diversity of species? Well, it's because partly they have, you know, different sizes, different shapes that are better matched to particular bees. Stay tuned for that work to be finished up and come out. This focus on kind of evidence-based management of green spaces is something that we really appreciate in the lab and we're continuing to work on. So our next big challenge, I'm jumping even further out of my, you know, tree-based comfort zone, and we're working closely with my colleague, Dr. Barbara Fry at Environment and Climate Change Canada, to try and find evidence-based practices that will support both nature-based climate solutions, things like carbon storage that we often advocate for in our policies, that also will support avian biodiversity and conservation. And so we have a lovely website down there that talks about many of the student and postdoc projects in this area. And so that's what's kind of coming down the pipeline from us in the next few years. So that was a really rapid overview of a few different kinds of projects we're working on right now in the lab that I'm excited about. Lots more that I didn't get a chance to tell you about, but through thinking about these things, we have some lessons that we've learned from working in the city for several years. On the first, cities are these areas of really high spatial heterogeneity that are constantly changing over time. And that makes them like a landscape ecologist playground. They're such an interesting place to ask spatial and temporal ecological questions while engaging local communities in science and in conservation. We know that we need to think about time. I didn't talk a lot about our kind of historical ecology work today, but we know that what we plant or the policies we're making are going to influence these systems for a very long time to come and continue to shape our biodiversity and services. So we need to be thinking long term when we make recommendations. And we need to be thinking outside the park. Parks are great. I love parks, but we have a whole urban landscape that happens outside of those. And so we see, the importance of street trees or backyard trees in providing benefits and reducing temperatures. And including this will give us kind of new insights into urban ecosystems. And we need to think about the small stuff. We need to think about what are the species that we're planting. A stronger understanding of these kind of site-based effects is going to help us understand the kind of situations and scales that we can improve ecosystem services and biodiversity. And finally, to end on a feel-good note, our actions really are important. I know people say this, but I really do mean it. I mean, the importance of private land, these kind of fine scales, that things vary, the implications of the choices our citizens and individual groups make do really make a difference. And it highlights the agency that local partners have in conservation and the value of spreading ecological knowledge amongst our cities. And so with that, thank you very much for listening, and hopefully I've left about 10 minutes for questions here at the end. You can also email me if you have questions you don't want to ask today, or come up and chat with me afterwards, and I'd be happy to answer.
Wonderful. Thank you so much, Carly, for a great presentation.
Thank you.
I realized that with the tree that we have in our backyard, we enjoy the view, but at the same time, it's benefit for our community. And if you zoom out, probably for city, country, and
Yeah, your tree is sort of an ecosystem.
Yeah.
It's not
Don't
just
think
yours.
that the tree that you're planting has a
Absolutely.
just a view. We don't have so much time for questions, probably time for 2 questions. I see Catherine. That's
I would defer to a student if the student has one.
I will decide. Just go ahead.
So two quick ones, Carly.
Yeah.
Thank you. This is so extraordinary. Thank you.
Thank you.
You're in Montreal.
Yes.
Passive heat affects when there's more tree coverage. What does that do in winter? And then the second question, a Truro kind of one. We just had Fiona run through us.
Yes.
Decimate.
Absolutely.
Trees. What strategies you might recommend?
Okay, great question. So first, heat in the winter. We don't do a lot of winter ecology in the lab. We do have some temperature sensors out this winter. I'm crossing my fingers the cold doesn't kill their batteries. But we do see in the winter, it's probably more important that we're thinking strategically about where trees are placed in terms of kind of wind breaks and relative to, homes, kind of direct effects on homes and energy use. It could actually be the opposite effect, where if you have trees around your home and they're blocking that sun, you're getting that cooling effect that you don't want in the winter. And so I think there's a lot of thought to be done on the kind of site-specific scale to think about those trees. One of the interesting things in our private tree work is we're seeing a lot of conifers that are maybe continuing to provide, particular benefits throughout the winter, especially in terms of things like windbreaks that we don't capture a lot in our public inventory because we're not planting them on streets. So short answer, don't have a great answer for you, but I do think there are winter effects that we should be taking into account that we're mostly ignoring because we're so concerned about summer heat waves right now. Truro question. Your second question was about Fiona. Yes, I was in Charlottetown shortly after Fiona for the Canadian Urban Forestry Conference, and this was a big topic of conversation where, we get these disturbances, these events that totally change the composition of our urban forests. In Montreal, we're still talking about the ice storm. And certainly these cause a lot of damage to our urban forests, and planting new trees takes a very long time to give us those benefits. So we always advocate for retaining trees wherever we can. Unfortunately, in the case of a storm, that choice is not yours. And so what it does give us is an opportunity to think long term and think about, now that we've lost so much tree cover, and we are thinking about replanting and what to bring in. How do we do this in a better way? And a lot of that is thinking about diversity, making sure we, have learned lessons from things like emerald ash borer or Dutch elm disease, that we're not planting the same species across a whole street or a whole neighborhood. I think there's still a lot of thinking to do in terms of how climate change is going to change the disturbances we have to worry about and the trees that are most resilient. And so strong storms, while the trees are in leaf, have a huge effect because of all that drag, more trees get taken down. As we see storms happening at slightly different times, weather happening in patterns we're not used to, we're going to have to think about what kinds of trees are going to be more resilient to that in the future. Also thinking about planting practice, because I know that we saw a lot of loss of relatively new young trees in Fiona because they weren't planted well. And so making sure that those are, appropriately integrated into our cities to give them the best chance of withstanding something like that. And so unfortunately, trees take a long time to grow. We can't snap our fingers and regrow our forest, but we can think strategically about how do we ensure that we have the most resilient forest we can when we replant these trees.
One question that Connie? Yes.
Hi Carly, Rick LaBrosse here, the Green Infrastructure.
Yes, we met this morning.
Morning, it's very good to see. Now I understand what you meant about the bees and.
Yeah.
We talked about this a little, but these urban ecosystems that we're sometimes trying to recreate
Mhm.
or bring back to what they
Mhm.
were. They often turn out to be hybrid of some sort.
Yeah.
Because of all the influences. But here in Truro and Nova Scotia mostly, we're trying to conserve the existing ecosystem.
Yeah.
Still have them perform
Yeah.
whatever ecosystem service provision, whatever you
Right.
want to do. I'm wondering if you have any tips and tricks that could apply to that kind of thinking.
To conserving what's already there. So that
Yeah,
is
even,
incredibly important. And we see this, we see this in Montreal as well, where we do still have, pockets of kind of remnant forest or green space or nature that are not protected yet, that we often see, really passionate citizen advocates or groups. And I would say, anywhere you can protect an existing green space, like do that before you try and recreate it. We see these scenarios where cities have goals for the amount of protected area, for example, and they're simultaneously like building a condo on a green space and then trying to re-green, an old parking lot. And what are you doing? Because we're not very good at recreating things. We're not very good, even if we're not trying to get back to a particular baseline, we're still not necessarily great at going in and taking an urban site and turning that into, a healthy functioning system. So I would say anywhere that we can protect, existing green space, intact green space, that should definitely be a priority. It's the same thing with trees. We talk a lot about tree planting because it's very actionable and it feels very good and we can take a nice photo. But you're much better off, protecting and retaining a tree that you actually have that's already, mature and providing these benefits than planting a new one. So I think certainly we need to focus on protecting the green spaces we have and ensuring that we don't, sprawl out into those intact green spaces with, with development. Urban sprawl, again, I'm not a planner, it's out of my wheelhouse, but urban sprawl is a big threat in terms of, biodiversity and protecting these spaces. And that's where we sometimes get into these sorts of tricky situations of, do we really densify and maybe lose some of the green space and services in the city, but are able to retain these larger green spaces outside? Do we have low density development where we can have more green space in and amongst the city, but then your city's going to get larger? And the answer to that probably depends on, what your goals are and what people want. But I do think really putting a priority on protecting the green spaces we have is absolutely the right way to go.
and it's the bigger picture too. It's from that landscape scale. Do we have enough vision, whether it's biomass or whatever?
Yeah.
To allow density to occur in this thing.
That's
Given.
Yeah, some of this comes down to the same challenge of, when we're thinking about the urban forest and we've cut our city into, thousands of different parcels that are all making different decisions. It's the same way when we zoom out, where we maybe have a municipality making decisions about, what's happening in the city, but with very limited jurisdiction outside, and someone else is making decisions outside. And so getting people in the same room at the same table, agreeing on goals is a really important part. And I think as an ecologist, I can do the work to tell you, if you want this outcome, here's a way to get there. But I don't know what the outcome is, that's a value judgment. That's something for people to decide, to, vote for what you want.
We don't have any question from the people online,
Okay.
but as a compliment for you, that's a great presentation and easy to follow.
Yeah.
I appreciate that.
Uh-huh.
So, before ending today's presentation, just a couple of points. There's a coffee and treats over there. You can just grab these when you are going out. And also I would like to thank you, a couple of people, it's like, Dr. Carly for coming down and Dr. Paulman for providing her name that we can just get in touch and invite, and my team, Jolene, and we do have Ren. And also Dr. Cutler and his, colleague from the research office, really appreciate, and join me and thank you for this great presentation. The recording will be available on the YouTube channel in case if you want to revisit or to comment or somebody else.
And if there are more questions, especially if you're a student and you don't want to ask a question in the big room, I'll hang around a little bit. You're welcome to, come up, say hi, ask your question. I'm not scary. Good time.